All right, everyone, get ready because we're taking a trip to Mars today.
Sounds exciting.
You guys send in some awesome articles about a new discovery,
Yeah.
evidence of hot water activity on Mars.
And
And hold on to your hats because this evidence,
yeah,
it goes back 4.45 billion years.
that's right. The oldest evidence of water on Mars that we've found so far.
We're going to do a deep dive for you today into two articles.
Great.
Excerpts from Discovery of Ancient Hot Water on Mars, Indicator of its Habitable Past, from NDTV.
Okay.
And Hot Water on Mars, 4.45 billion years old, rock reveals Mars may have held the key ingredient for life. That one's from the Times of India.
All right.
They both talk about this amazing find.
Uh-huh.
And we're going to break it all down for you today.
Okay.
We're talking implications for life, maybe even how we understand Mars's history.
It really makes you question everything we thought we knew about the red planet.
Right. Okay, so let's paint a picture here.
Okay.
This discovery starts with a meteorite.
Okay.
Scientists call it Black Beauty.
'Kay.
Officially, though, it's NWA 7034.
Ah.
This meteorite landed in the Sahara Desert back in 2011.
Okay.
Now, Black Beauty itself is about 2 billion years old.
All right.
But here's the crazy part.
What?
Scientists found a little zircon grain inside.
A grain.
Yeah, a zircon grain. And that tiny grain is 4.45 billion years old.
So that tiny grain's like a message from the past.
Exactly, like a little time capsule from 4.45 billion years ago.
Wow.
So this zircon grain, it's not just old. It's telling us something important about water on Mars.
Yeah.
But before we get into that, I gotta know,
What's that?
what's so special about zircon?
Oh, zircon is amazing.
Yeah.
It can withstand crazy heat and pressure, which means it holds on to information about where it came from.
So it's like a window into what Mars was like billions of years ago.
Exactly.
So what does this ancient zircon window show us?
Well, scientists looked at the chemical makeup of this zircon grain and found what we call geochemical fingerprints.
Geochemical fingerprints.
Yeah, think of them like clues. And these clues tell us that there were water-rich fluids when this piece of Martian crust was forming.
So not just water, but hot water.
Right.
You're saying this could mean there were hydrothermal systems on Mars?
It's possible.
Hold on a sec. We used to think early Mars was cold, dry, and desolate.
Right.
Now we're talking about hot water.
It seems like our picture of early Mars was maybe a little too simple.
I guess so.
This finding suggests a much more dynamic environment and, maybe even an environment where life could have existed.
Okay, so hot water.
Yeah.
And you mentioned hydrothermal systems before.
Mm.
For those of us who haven't taken a Martian geology class lately, could you break that down a bit?
Sure. So imagine volcanic activity deep under the surface,
Okay.
generating heat.
All right.
And that heat interacts with water, creating an environment with lots of chemicals and energy. Now, on Earth, these hydrothermal systems, like underwater hot springs, are full of microbial life.
Oh, wow. So like those deep sea vents you see in documentaries.
Exactly.
Full of those crazy-looking life forms. So if something like that existed on Mars billions of years ago, I mean, that's mind-blowing.
It really opens up a lot of possibilities.
That's an understatement.
Makes you wonder, right? And there's more.
What's that?
This hot water activity, it happened before what we call the late heavy bombardment.
A late heavy bombardment.
Yeah, when Mars was getting hit with all those meteorites.
Oh, right. So this wasn't just some quick warm period.
Nope.
We're talking about some serious water systems that could handle a lot of chaos.
Exactly. It makes you think, if life did start on Mars during this time,
Yeah.
this early period, could it have survived all those impacts?
Now you really get me excited.
Uh-huh.
But before we get ahead of ourselves,
Right.
let's go back to the zircon.
Oh.
The articles you sent mentioned some super precise techniques they used to analyze it.
Ah, yes. Nanoscale geochemistry.
Nanoscale what?
Nanoscale geochemistry. They're basically using tiny lasers.
Tiny lasers.
Yeah, to analyze the chemical makeup of this little grain.
Like microscopic lasers. Sounds like something straight out of Star Wars.
Kinda, haha, but that's how they confirmed the presence of water.
So it's not just that there was water.
Right.
They found specific elements that point to a water-rich environment.
Exactly, like certain types of oxygen.
Isotopes.
Yeah, isotopes. It's like reading a chemical history book.
And each element's a clue.
Exactly.
So this one little zircon grain is rewriting history.
It really is.
But how does this change our understanding of how Mars formed and changed over time?
Well, we knew Mars had a wetter past, but we thought that started later, like around 4.1 billion years ago.
Okay.
This zircon grain, though, it pushes that timeline back.
So it's possible that the right conditions for liquid water and maybe even life
Yeah.
They existed much earlier than we thought.
It seems that way.
So we're not throwing out the old textbooks completely?
Nope.
But we are adding a new chapter.
A pretty important one.
What does this mean for the search for life on Mars today, though?
Well, it definitely makes things more interesting.
How so?
We're not just looking for signs of ancient life anymore.
We're looking for life that had more time to evolve.
Exactly. And the possibility that some kind of microbial life might still be hanging out under the surface, maybe in those hydrothermal systems.
It's pretty exciting.
It is.
So what do we do now? What are the next steps to learn more about this early Mars?
Well, first we need to find more zircons like this one.
Makes sense?
Each one could hold a ton of information.
Okay, and
And we need to adjust how we explore Mars.
what do you mean?
Well, if hot water was common on early Mars,
Yeah.
then the best places to look for signs of life would be where those hydrothermal systems might have been.
Like those ancient lake beds we see in the pictures from space.
Exactly. We need to send missions to those places.
Okay.
And those missions need instruments that can find what we call biosignatures.
Biosignatures.
Yeah, chemical traces of past or present life.
So basically robots that can sniff out Martian microbes.
You got it.
That's awesome.
It is.
What kind of missions could do that? Are there any planned that can help us learn more?
There are a few that could make some big discoveries.
Like what?
Well, there's the Mars Sample Return mission.
Oh, yeah. That one's going to bring back samples from Perseverance, right?
That's right.
That little rover is collecting rocks and soil.
Yeah, and when we get those samples back here on Earth, we can analyze them with much more powerful instruments.
Stuff we can't send to Mars right now.
Exactly. We can look for organic molecules, analyze isotopes, even search for fossilized microbes.
Bringing pieces of Mars back to our labs.
It's a game changer.
Sounds like we're on the edge of some huge discoveries.
We are, and this discovery all from one little zircon grain.
I know, it's amazing.
It shows how important it is to keep exploring.
We never know what we'll find.
You got it.
This is where I get a little excited.
Uh-huh.
We could be talking about finding proof that we're not alone in the universe.
It's possible.
But even if we don't find little green men, just learning about Mars's past helps us understand our own planet.
And the possibilities for life on other worlds.
It's mind-blowing.
It really is. I'm excited about it, too.
Okay, so we've talked about a lot today.
We have.
From this ancient zircon grain to what it means for finding life on Mars.
Yeah.
You've definitely given me, and I'm sure our listeners, a lot to think about.
I hope so.
But before we wrap up,
I
have one last question.
Okay, shoot.
This zircon grain, it's the oldest evidence of hot water on Mars that we've found.
Right.
But could there be even older stuff out there?
That's a great question, I think. That's a great question. I think it's definitely possible, you know? This one tiny grain has already changed how we think about early Mars.
It really has.
So who knows what else we might find out there.
That's what I like to hear. So if we did find even older evidence, what would that mean? Would it be a total game changer?
Well, imagine finding evidence of water activity going back even further, maybe even to when Mars was first forming. That would mean there was even more time for life to start and maybe evolve on Mars.
So a bigger window than we think now?
Exactly. It could even change how we think about how fast life can appear on a planet.
Wow. Now, those are some big implications.
They are.
It's incredible to think that one tiny grain of zircon has opened up so many new questions.
It shows you the power of discovery, doesn't it?
It does.
Every new finding, even a tiny one, can change everything we thought we knew.
So true. All right, before we let everyone go, I need you to help us sum up what we've learned today.
Okay.
What's the big takeaway from this deep dive into hot water on ancient Mars?
Well, this discovery with that single zircon grain, it's given us the oldest proof we have of hot water activity on Mars.
Oh, wow.
And that suggests that Mars could have been a place where life could exist.
And much earlier than we thought before.
Right. It makes us rethink what early Mars was like and opens up some exciting new possibilities for finding life out there in the universe.
It's like we got a whole new map of Mars and we're just starting to explore it.
Exactly. And as we keep exploring, who knows what else we'll find?
Well said. Big thanks to you for taking us on this incredible journey.
My pleasure.
And to all our listeners, keep those questions coming and never stop exploring.
That's right.
Until next time, stay curious.